I asked this question on Facebook, and no one knew the answer. So I decided I should discuss why nail plates snap off at the free edge rather than split down the length of the nail plate. Here's the reason why. The reinforcing bonds that hold the nail cells together, they form randomly in all directions. So there's bonds forming from every different direction. So it would be expected that the nail plate would be equally resistant to cracking in all directions. Clearly, that's not the case. The nail plate is highly prone to breaking in one direction across the width of the nail plate. Only in unusual circumstances does it split or break down the length of the nail plate. Now, the reason for this is in the internal structure of each nail cell. Each nail cell is filled with many short strands of keratin that are called fibrils. Fibrils have the appearance of tiny small fibers. Now, these fibers aren't randomly distributed, but instead they're uniformly stacked into neat piles, much like logs of wood are stacked. These stacks of fibrils lay across the width of the nail plate, with their ends pointing toward the sidewalls. This arrangement makes it easier for a crack to travel between the fibrils rather than across or running through them. That causes cracks to turn toward the sidewalls and prevents the crack from spreading down the length of the nail plate. Cracks move like water flowing downhill. They take the path of least resistance. This results in helping to prevent the nail plate from splitting in two and exposing the underlying nail bed. In this way, the nail plate protects itself from catastrophic injuries that could lead to serious infections. The nail plate can split down its length, but when it does, the crack often is following a deep groove in the nail plate. Since the nail plate is much thinner inside these grooves, it's much easier for a crack to follow along the groove if it offers the path of least resistance. These nail plate grooves can be caused by nail matrix damage, or they can be a result of just normal aging. I discussed grooves in episode 11 when I explained that there are no ridges in the nail plate, only grooves. You should go back and take a look at that episode. The nail plate does develop shallow grooves where the aged or damaged nail matrix isn't working as efficiently and it's making fewer nail cells, so the nail plate grows a little thinner down that strip. Now, when the nail plate develops these grooves, don't file the nail down to make the nail plate as thin as the deepest groove. That's not a good idea. Instead, it's a better idea to use an opaque base coat to fill and cover the grooves. This will maintain the thickness and integrity of the nail plate and help to prevent splits. Of course, overlaying the nail plate with a thin layer of any type of artificial nail coating can also camouflage the groove, and it can reinforce the nail plate while improving the appearance without over-thinning, which will greatly reduce the chance of future splitting, I should say.